Okay, I want to start this module off, or this video off, with giving you the electromagnetic spectrum, and then we're going to talk about how we can produce it. So, electromagnetic radiation or electromagnetic energy, I have this line here. It is radio waves, microwaves. Now, some books, if you're looking at books, they will combine those two. I like to keep them separated. Infrared radiation, infrared, visible light, ultraviolet rays, X rays, and gamma rays. Okay, so these are the 7 components of the electromagnetic spectrum that we deal with. And in reality, everyone is familiar with some of these at least. Radio waves, I know you're very familiar with. We'll talk more about that here in a little bit, and potentially in the next video, because I want to make sure we get into the chemistry in this video. X-rays. So some things that these guys have in common, they all travel at the speed of light, but they're also very different. And so how can we produce X-ray radiation? How can we produce radio wave radiation? And they're all produced the same way. So what we want to do is first look at an atom and go back to the atom. So we want to look at, remember we have a nucleus of protons and neutrons. And remember these energy shells that we talked about in the chemistry modules, where the electrons like to be? Okay. And so remember we said that the electrons fill in when they're at the closest point and they work their way out. Okay. And electrons at their lowest energy level, when they're at their lowest energy state, they will be as close to the nucleus as possible. So in this picture right here, I'm going to call the black image 1, the electrons they're not produced, they don't have a lot of energy, they're chilling out. But what happens? So for example, if I were teaching in a room, what I would do next is I would add energy to the atom. So for example, when you walk into a dark room and you flip the switch, the light switch, you've added energy to the atom. So I'm going to add energy to the atom. Now remember, the electron is lower mass. So it's going to absorb this energy faster and easier than the protons and neutrons. So the electron is going to absorb the energy. Okay. And now the electrons are high energy. So what happens next is the electrons then jump out to higher energy states. So if I had another one here, it may only jump out to here. If I had one here, it may jump out to here. So they're all jumping at different energy states. So now the electrons jump to higher energy levels. Okay, they're excited. So they're bouncing around out somewhere with high energy. And if you think about it, if you give a kid a Twinkie, they get hyper bouncy and they're bouncing around and they got to wear this off or work it off and run it off. So the electron wants to get rid of this energy. The electron doesn't like to be high energy. It wants to be low energy. It wants to find that lowest energy level. And so the electron wants to release the energy. So now that the electron has jumped out, okay, so it wants to release this energy. So it releases an energy bundle, basically kind of, this is going to sound weird, it just kind of throws its energy out. So it releases its energy as a photon. Okay, a photon is an energy bundle. It is light. What you're seeing is photons flying through. So we have these photons. So the type of photon equals the amount of energy released. So let's look at that with this picture here. So right now I have these 4 electrons that are out here, okay? So let's take this electron and let's say it jumps all the way back down in. But let's take this electron and let's say it only jumps to here. So we'll call this A, we'll call this B, call this C, and call this D, okay? So we have, I want to specifically just look at A and B. So electron A downward is not a great word, but to a lower energy level. Okay, so the electron A jumps more energy levels to get to a lower energy level. So it's jumping more energy levels, so it's released more energy than electron B. So the photon for A has more energy than the photon for B. Okay? And you're like, well, so what does this have to do with this? Well, if it has more energy, if you think about something, if it has more energy, is it going to be more higher frequency or lower frequency? Well, if it has more energy, it's going to be a higher frequency. So because it has more energy, it's got a higher frequency. So the photon for B will be lower frequency. And now let's go back to the electromagnetic spectrum. All travel at the speed of light. Which is equal to C, which is equal to 3 times 10 to the 8 meters per second. So C is equal to the wavelength times frequency. So if we're looking at this, C is constant. So that means the right-hand side is constant. So if my frequency gets bigger, then I'm going to have a smaller wavelength. If my frequency is small, then I'm going to have a bigger wavelength. And so that's what we're going to do in the next video, is we're going to go through and start looking at how do radio waves and X-rays compare using this concept. But before we do that, before we jump to the next video, I want to talk about the speed of light. What is 3 times 10 to the 8 meters per second? Like, really, how fast is it? Like, what does that make sense? So this is 300 million meters per second. Well, that really, I'll just say to myself, that doesn't mean a whole lot to me. But I know that a football field from end zone to end zone is 100 yards. And remember, 1 meter is greater than 1 yard. So we're going to estimate. We're going to say that this is approximately 100 meters from goalpost to goalpost. We're going to estimate, okay, 100 meters. So if I take this and divide it by 100 meters, get rid of 2 zeros, that is 3 million football fields per second. That is how fast light travels, approximately. I'm estimating it, but I'm trying to help you visualize 3 million football fields per second. So light is flying. The electromagnetic spectrum radiations will change depending on what it's in, but if it's traveling in a vacuum, it should travel at the speed of light. So, and again, in the next video, we're going to take this electromagnetic spectrum and talk about how these photons produce X-rays and gamma rays. So if it's a high frequency, what is it producing? If that photon is a low frequency, what is it producing? And so now we're going to go through and start dissecting the electromagnetic spectrum.